Hi all, and in this video we're going to talk about the PLC timers that are available in the Rockwell CCW software. So you take a look at it. It says that the timers that are available is we have 5 timers available. We have a TON timer, which is a timer on delay, a TOF timer, which is timer off delay. This series has a timer on off delay timer. There's a RTO timer, which is a retentive timer, and there's a TP, which is a pulse timer. So before we go to the software and actually do the timers, I want to just do a brief run through as how timers work. So let's take a look at the TON timer. The timers actually have 2 forms to them. One of the timers can be put in without an enable, and another one can be put in with an enable. And these options, or the option to include enable, is available when you're creating the timer. And I'll show you that when we get into and do it in the software. So I just wanted to mention that now because they can all have an enable added to them. So the inputs to this timer are input. It's labeled as in on either one of the timers. Now, in order for the timer with the enable input to function, the enable input has to be true. Without the enable, naturally, there is no enable, and the timer will function when the input connection goes true. So when the input line of the timer goes true, the timer will start timing. Now this is a timer on delay timer. So that means whatever the timer is controlling will be off until the timer times out. Henceforth a timer on delay timer. The PT is the preset time. And that preset time is how long can that timer time. This timer can time up to 1,193 hours, 2 minutes, 47 seconds, 294 milliseconds. And that's because it's a 32-bit preset. And again, when we get to the software itself, I'll show you how that gets entered in. The outputs of a timer, on the enabled timer, there is an enable output, which will be true when the timer is enabled. The Q output is the same as what the done bit would be in the Rockwell Studio 5000 version of the software. So that bit will turn on when the elapsed time, the ET, is equal to the preset. So that's basically the done bit of the timer. And the ET is the elapsed time of the timer. In other words, it's the accumulator of the timer, and it will show the current time on that timer. Now, timer on delay timers will time when the input is true, and they will stop timing and reset when the input is false. This timing diagram shows that functionality. When the input is false, the Q is false, the extended time is at 0. When the input goes true, the ET starts to time. This is a timer on delay, so the output's not on yet because the timer has not finished timing. When we get to the preset time, the Q turns on, and the Q will stay on until the input goes false. Once that goes false, the timer resets and the Q turns off. When the input turns on again, the timer will start timing, but if the input turns off before I reach the preset time, the timer resets. So they work exactly the same way as the timers in the Studio 5000 software. It's just that the designations for preset and done and accumulator are labeled differently. Timer off delay timers. They also work exactly the same way as they did in the Studio 5000 software. Timer off delay timers turn the output that they're controlling off at the end of the timer. There's another difference, is that these timers time when the input is false. So I have the input, I have inputs as inputs, I have the preset time, I have this one has the enable, this has an input and a preset, we have a Q output, which is the done, and we have an elapsed time. So in this case, the input is false, the Q is still false. The input has to go true. When the input goes true, the Q turns on, or the done bit turns on. Then when the input goes false again, the timer will start timing. The Q will remain on. When the accumulator, or the elapsed time, is equal to the preset, the Q or the done bit will turn off. When the input goes true, the timer will reset. So the timer will reset and the Q output will turn on. After this time, if the input goes true, the timer will reset even if it's not finished timing. So they work exactly like they did in the Studio 5000. The Rto timer also works exactly like it did in the Studio 5000 series. The difference here is that this timer has an input for reset. So this timer, instead of having a separate reset, an instruction like the Studio 5000 software had, this one has a built-in reset. And when the reset goes true, the timer will reset. And you can tell by the timing diagram that this timer will work exactly like a timer on delay, except that when the input goes false, if the timer has not finished timing, it will hold the value of the elapsed time, so that when the rung goes true again, or when the input goes true again, the timer will start timing right from where it left off. So it retains the value of the elapsed time. Now this series of processors has something called a timer on-off timer. And this is, I actually have never seen one before this. This timer will perform a timer on and a timer off function. It has two preset inputs. One of the inputs, this preset input, is for the timer on delay function, and the PTOF, which is the preset for the timer off delay function. Therefore, the timer will act exactly like a timer on when the rung transitions from false to true, or when the input transitions from false to true. And it will act as a timer off delay timer when the input transitions from true to false. And we'll demonstrate how that works also when we get to the code. The TP timer, or the pulse timer. This one is not available in the Studio 5000 software. This has an input. It has a preset time, it has a done bit Q, and it has an elapsed time. But this is basically a TON timer, but it functions in a very special way. And let's take a look at this timing diagram. When the input goes true, the Q output goes true, and the timer starts timing. When the accumulator or the elapsed time equals the preset, the Q turns off. When the input turns off, nothing happens, or turns off, the accumulator resets. The accumulator resets. Now when the input goes true, the Q will go true, the timer will start timing. But take notice, if the input goes false before the timer is done timing, the timer keeps timing, and the Q will remain on, no matter how many times the input transitions from true to false. And when the timer is done, the Q turns off. So it's a pulse timer. When the input turns on, it starts timing, the pulse turns on, and when it's done, the output or the done bit turns off. All right, so from this point in time, we're going to go to the software and actually program these timers. So I've already created the project, and I have a simulator in the project. So let's create a routine. So under programs, I'm going to right click, I'm going to say add a new ladder program, and I'm going to rename this to, I'm going to call it TON underscore timer. Now I can't just call it TON because TON is a reserved word. It's the name of an instruction. So I'm going to call it TOM timer. I'm going to press enter. And then I'm going to double click on it to open that routine. Now to enter a timer, I can go across the top menu here and look for timers. However, the easy way to do this in CCW is to come onto the toolbar and take an instruction block. And you drag the instruction block to a target and drop it. And when you do that, the instruction block selector will appear. Now there's a whole list of instructions that you can use as blocks. I'm going to just search for the timer on delay. So TON, and it tells me here's the TON timer. And it's already selected for me. The instance is the tag name or the variable name of the timer. I can leave that just as it is if I would like, or I can change it simply by clicking in there, and I'm going to say TON timer example. You could name it anything you want. This checkbox is where you would put the check in if you want to turn the enable input on or off. So let me turn that on for this version of the timer. And then we click OK. And when we click OK, we get a timer on the rung. And you'll see that the variable name I gave it is displayed across the top. Now we're going to make this timer function. So let me drag in a normally open contact, and I'm going to give it a tag name. This is the enable, so I'm going to say TON enable. It's going to be a bool data type, so I'll just say OK. Notice that the input, you can't put a contact on it, but that's okay. All you need is a variable name there, and it'll look at the variable name and whether the variable is true or false. Now there's two fields basically in this timer field. to create a new variable, I'm going to double click on the bottom field, and it's going to then open up my variable selector. Now, I'm creating all these variables in local scope, which means I'm not connecting anything to the field I/O. And for this example, I'm not going to use any field I/O. I'm just going to use internal bits, and then I'll show you we can toggle those bits on and off without having to go back to the simulator and click on an input point to toggle it. So I'm just going to create another variable here, and I'm going to just call this TON in and press enter. And that created the TON input bit. Now I need a preset. So let's do a preset value of, let's say, 5 seconds. I want to enter a value in here. I'm not going to be using a variable. I could, but I'm not going to be using a variable. So I'm going to click into the top field, and immediately you get a drop down. Now, if I had a tag or a variable already created, I can scroll through this list and choose it from the list. But I don't have a tag. I don't want a tag. I'm going to enter in 5 seconds. To enter preset values, you enter a T with a hash mark and the amount of time you want. And I want 5 seconds. So I'll just put 5S for seconds. If I wanted minutes, I would make that an M for minutes. If I wanted hours, I would use hours. If I wanted milliseconds, I would use MS for milliseconds. So I'm just going to use 5 seconds and press enter. This is now set for 5 seconds. The Q bit or the done bit, I'm going to create a tag for that. I'm going to double click on the bottom. I'm going to create a TON done bit. And that's the bit that will turn on when the timer's done. I don't have to, if I don't need the enable, I don't have to use this enable output. But if I do, all I have to do is bring an output energized coil, drop it on the target, give it a tag name, TON enable, and that bit will turn on, or that coil will turn on when the timer is enabled. Same with the accumulator. I don't have to tell the accumulator to start at 0 like I did in the Studio 5000. I can just leave that blank if I don't need the accumulator value. It will still display the current time, but if I don't need it, I don't have to put anything there. I don't have to assign it even to a variable. And at this time, I'm not going to. I'm just going to leave that blank. All right, I'm going to add one more timer without the enable bit on it. So let's drag another rung in. I'm going to bring another block in. I'm going to search for timer on. I'm going to just leave the instance name as it is. I am not going to check the enable. I'm going to say OK. I'm then going to add a contact, and I'm going to call this TON, I don't know, without enable. Let's say TON in without enable. You could call these anything you'd like, just as long as you know what they are. I'm going to give this a preset value of also 5 seconds. And I'm going to put, now this time I'm going to put a coil on the Q output, because this will be my done bit. And I'm going to say TON without enable done. And this program's ready to run. So let's run it. Now, before I run it, what I did not do was I did not set up a communication path. So I'm going to go back to my Micro 850, and if that tab isn't available, just double click on Micro 850, and I'm going to create a connection path. In this corner up here it says connection path. But before I can do that, I have to turn on the simulator. So on the toolbar, find the button that's labeled Start Micro 800 Simulator. So I'm going to start the simulator. I'm going to then turn the simulator on. And remember that IP address. Now I'm going to come over to where it says Connection Path. Click on this Setup Connection Path. And I'm going to find that particular IP address. Looks like I have it in 2 Ethernet paths. Let me select the first one. I'll double click on it and say close. So now my path is selected. And then I'm going to download this by clicking the download button. And if I didn't make any errors or any mistakes, this should download. As we wait for this to happen, this particular laptop doesn't have a lot of resources available, so it takes a little longer. Oh good, no, it succeeded. I had no errors. So let's keep going. Yes, I want to download it. I want to go to run mode. So I can see it went from program mode to run mode, and we are now connected. I'm going to close this bottom window just to get out of the way. The simulator is running. I don't need to see it to do what I'm going to do. So you'll see that when the rungs are blue, they're not energized. When they're red, they are. You'll also see that it tells you the status of the bits. So this one is false. This one is false. It tells you the timer accumulator is at 0 seconds. So let's start with the first timer on timer example. Remember, this timer, the enable has to be true before anything can happen. So I'm going to turn the enable bit on by just right-clicking on the timer enable instruction and saying toggle the Boolean value. The other way you can do that is to click on the instruction and just type Control+T key, however you prefer. So I'm going to turn that on, and notice that the rung, that part of the rung turned red, which means I have power flow, and the enable turned on. But the timer's not timing yet because the input did not turn on. To turn this on, I'm just going to click on there, right click, and say toggle bit. It goes true, the timer starts timing, and when it reaches 5 seconds, the done bit turns on. That's how easy it is. When the rung goes false, when the input goes false, the timer resets. This timer will work exactly the same way. Toggle this bit. The timer will start timing. When it's done, the done output will turn on, which it just did. Now for the enabled timer, if I needed a coil to turn on with the done bit, I could have simply added a rung with a contact on it with the tag name TON done. In fact, let me go offline real quick before I end this video. Let me go offline. I'll just click the connection button. Let me do that while we're here. Let me add a rung. I will then add a contact, and I want to use the TON done bit or done variable as my contact variable. So TON done, okay. I am then going to put a coil on here, and I have to give it a variable name. TON done coil. I'm not getting very creative here today. And say okay. And then I'm going to download this. So since the simulator's still running, I'm just going to download it. And again, hopefully I didn't make any mistakes. And we'll say download. And if it ever gets downloaded, okay. Okay. You can turn that one dialog box off that says about the timer or the simulator only running for 10 minutes if you'd like. I leave it on because I'm creating these videos. I'm going to close that to get it out of the way. And this time I'm going to enable this timer. And I'm going to get this timer to start timing. And this time when it's done, this coil will turn on because that Q bit turned on. It's that simple. The one thing that these timers do not have that the Studio 5000 timers have is these timers do not have a timer timing bit. But we can create a timer timing bit. If you know how the timer works, you know that the timer is timing when the input is true and when the accumulator is less than the preset, or when it's not done. So we can create a timer timing bit. And before I leave you, I don't want this video to get much longer, but before I leave you, let's do that also. So I'm going to disconnect. I'm going to add another rung to this. And this time, let's see, the timer is timing when the input is on. So let's put a contact in. And that was the TON in. So when it's input and when it's not done, not done. Not means I'm going to use a normally closed contact and use the TON done. And then let me put a coil on here, and I'm going to call that coil TON timer timing. So this should give me the function to let me know when the timer is timing. If I didn't do anything wrong, this should work fine. So let's download it. Every time you make a change, you have to download. And let's hope I didn't make any mistakes. Everything looks good. We're going to download it. Okay. Let me get rid of the bottom window. Note that the timer on DN is closed because it's normally closed. Even though the output is false, the coil's not wired, therefore the normally closed contacts are closed. And let me enable this timer. and start the timer. So while this timer's timing, this output should be on. That output is on, the timer's timing. And when it gets to 5 seconds, it's done and it's no longer timing. So you can create what you need if you understand how timers function. All right, I'm going to end this video here and create a part 2 where I'll demonstrate how all the other timers work, but also I want to show you the difference in how this software handles subroutines, because it's very different than the Studio 5000. Thanks a lot. I'll see you in part 2 of PLC timers.